All right, so now we're going back a little bit to lines. Okay, so it's a pretty good mix here, Module 7, 8, and 9. 7 and 8, you have the rational functions, then Module 9 gets a little bit easier, goes back to lines. So the slope of a line, rise over run, counts the steepness of the line. If I'm looking at it on a graph and I wanted to count from this point to this point, I could make a triangle and count the rise and then count the run, and I could get that slope. I think this is a little hard to see, but I think here this goes 1, 2, 3, so it goes up 3, and then it goes over 1, 2, 3, 4, 5. So in this, that should be a 5. In this graph, the slope here would be a positive 3/5. Okay, we use m to denote slope, so we say m is 3/5. The equation for the slope between 2 points on a line is given here. So it's y2 minus y1, that's the change in the rise, okay, because the y-axis goes up and down, over x2 minus x1, that's the change in the run, because the x-axis is that horizontal axis. So if I'm finding the slope between 2 points given to me like so, I can label them as x and y1 and x and y2, and then I can plug them in to this formula here. So I have y2 is 1 minus y1 is 1 over x2 negative 4 minus x1 3. 1 minus 1 is 0, negative 4 minus 3 is negative 7. 0 divided by negative 7 is 0. So the slope of this line is actually 0, and that can actually happen. Does anybody know what a line with a slope of 0 looks like? It's completely flat. It doesn't rise. It just goes like this. So let's take a look at this example here, which is already done for us. Okay, so you have your x and y1, x and y2. y2 is negative 10 minus negative 8, turns into a plus there, gives us 2, or negative 2. But then 5 minus 5 in the denominator gives us 0. And 2 divided by 0 is a no-no. So the slope of this line, when that happens, is going to be, you guys remember what that one is? Undefined. Good. And what does that line look like? Straight up and down, yeah, vertical. That's not vertical. I can't draw. There we go. Okay, vertical line, because look, it's rising, but it's not running anywhere. All right, slope-intercept form of a line is y equals mx plus b. M is going to be the slope. That's the number in front of x. B is by itself. That is the y-intercept. If I am given a line or an equation in these forms here, those are going to be general form or standard form. What I want to do to find the slope and y-intercept is to isolate the y. So that is rearranging the equation so that y is by itself. So in this first case here, I would take that 5x and subtract it from both sides. It's going to cancel out over here and bring a 4y down. I cannot do negative 5 minus 5x because they're not like terms. That 5 doesn't have an x. I need to write them next to each other. You want to put the x first. So this x, this 5x, has a minus sign in front of it, so it's a negative 5x. This 5 here has a negative sign in front of it, so it's minus 5. And then divide everything by 4. Okay, these 4's cancel, so y gets isolated. Then you have negative 5 over 4. We just write as negative 5/4, put the x in the middle, minus 5/4. And then this is in y equals mx plus b form. So the m is this negative 5/4. The b is also negative 5/4. So the slope is the m, the b is the y-intercept. So let's do that again with example 2. We would take the 6x, subtract it from both sides. That would bring down a negative 2y equals, we would do negative 6x. The 10 has a negative in front of it, so minus 10. And then I'm going to divide everything by negative 2. So these cancel. I get y equals negative 6 divided by negative 2, positive 3x. Negative 10 divided by negative 2, positive 5. And then m x plus b. So my m, positive 3, b, positive 5. Okay, so the equation, so we did those slopes before. If we're missing an x or an y, that will give us the equations of either vertical or horizontal lines. So for example, this line is vertical. It is going through the x-axis. So the line that it crosses is the equation. So if it's crossing the x-axis, it's an x equals line. And it's going through negative 6. So the equation of this line is negative 6. And the slope is undefined. An equation of y equals negative 6 is going to go through the y-axis. So this one here is negative 6 on the y-axis. The only way to go through that is with a horizontal line. You can't go through a vertical axis with a vertical line. Okay, so it has to be horizontal. Okay, so the line would look like this. It's y equals and a number. So notice the equation, it's x equals and a number. It doesn't have a y in it. Y equals and a number. It doesn't have an x in it. And then the slope of this one is 0. So for these two examples, we have what is the slope of the line x minus 4 equals 0? So here I'm going to add 4. And I get x equals 4. So it's an x equals line. It is missing a y, which means the slope is undefined. Okay, it's x equals and a number. Y equals 10, what is the slope of that one? Y equals and a number? 0. Good. Okay, and then I think we just have this one more thing with parallel and perpendicular lines. So this is comparing the slopes. So parallel slopes are never going to parallel lines are never going to intersect. So their slopes are going to be the same. Okay, because they're rising and running at the same rate, which means they'll never cross. So if you look here, M1 is equal to M2. The slope of line 1 equal to the slope of line 2. Exactly the same. Perpendicular lines have slopes that are opposite reciprocals of each other. Okay, so they're going to cross at a 90-degree angle. Opposite means opposite signs. So one is positive, one is negative. Reciprocal, they're flipped. Okay, so if you look here, you have line 1 is 1/3. The perpendicular slope would be a negative 3/1. So you flip that. A line with a slope of positive 5, okay, the perpendicular slope would be negative, and then we'd flip that. It's a whole number, so we say it's over a 1. So it would flip to be negative 1/5. And then negative 2/7, you'd have a positive, and then flip to 7/2. So for these examples here, you want to compare two lines and say whether the slopes are parallel, perpendicular, or neither. You have to find the slope of each line and then compare. So if I look at my first example, I have negative 12x plus 2y equals 1. I have to get that in y equals mx plus b form. So I'm going to add 12x to both sides, which would give me 2y. This would be positive 12x. The 1 doesn't have a sign in front of it, so it's a positive 1. And then divide by 2. Okay, that would give me y equals 12 divided by 2, 6x plus 1/2. So the slope of this line is 6. So we need to find the slope of the second line. So the second line is 6x minus y equals 7. So I'm going to subtract 6x from both sides. That's going to give me negative y equals negative 6x plus 7. I'm going to divide everything by negative 1. And that will end up giving me y equals positive 6x minus 7. So that slope is also 6, which means these lines are parallel. Then in example 2, you're just given one line and asked to find the slope perpendicular. So find the slope of this first line, which is negative 3. So then the perpendicular slope, opposite sign, so it would be positive, and then we would flip it, which would be 1/3. So the slope of a line perpendicular, positive 1/3. And that's all we have for this section.